In the previous video, we have implemented our player input script that gets the input from the player and our iInput interface that will be useful when we are creating an AI agent. Now let's get those informations from our delegates by creating an agent controller script. So let's create a new C# script. Let's call it agent controller. Okay, let's open it up. We can delete everything from inside of the script, and what we will need to do here is call iInput because we want to have the reference for our interface type. Let's call it input, and in the start method, let's tab to create it. We can call input equals get component of type iInput. Okay, so now we have our input, the reference value, and what we can do is currently we can assign to it input dot on movement the direction input. We can plus equal a lambda expression, and here we can get the vector3 reference. Let's call it input. So currently we do not have anything to assign to it, so let's assign a lambda expression. Let's get inside it input, and let's simply print it. So let's debug.log, and let's print direction plus our input. Okay, and let's create the same thing for on movement input. This time we are going to get the vector2. So let's copy the above lambda expression, and we need to finish this statement. Okay, and what we will need to do is change the direction for the movement input. Okay, so let's go back to Unity. Great, let's choose the player. Let's add here the agent controller, and when we press play, we should see input is printed, and if we press WSAD or arrows, we can change the movement input values, and the directions changes when we are moving with our mouse with our Cinemachine Free Look Camera. To exit the mouse locked, let's press escape, and let's stop the game. Now what we need to do is to create our agent movement script. So let's do that. Let's create a new C# script. Let's call it agent movement, and let's open it up. Okay, let's delete everything from inside of this script, and this script will do three things. We want to move our player forward. We want to rotate our player towards the direction that we have from our input manager, so in the direction of our camera, only when we are moving forward. And third thing is to play the correct animation. So we are going to do this step by step. First, we want to get the reference to our character controller. So let's create character controller. Let's call it controller. Okay, and on the start, we are going to call controller equals get component of type character controller. Okay, great. Now to use character controller, we need to apply gravity manually because we are not using rigid body. So what we will need to have is a couple of public floats. So let's create public float. First will be rotation speed. Second may be movement speed. And at last we can create gravity and set its value to, for example, 20 for the start. So this will be the gravity that we will apply to y-axis and call move our character controller towards the ground to detect the collision. Okay, and we also want to have a vector3. Let's call it movement vector equals vector3.0. So this will be the vector in which we want to move our character. And at last we want to have a private float. Let's call it desired rotation angle. And let's set it to 0 this will be the angle that we will want to preset for our character when we get the input. But first, let's tackle getting the input to move our controller. So what we will need to do is have public void on handle movement. And this will be assigned to listen to our input delegates. So this will be assigned to on movement input. So we will need here to get a vector to input. Okay. Now what we will need to do is to check if our controller, which is our character controller, is grounded. Because if we are jumping or falling, we do not want to be able to move around. So that's simple. Now, what we will need to do is to check if our input .y is greater than 0. And this is simply because we have only implemented the animation to move forward, so to walk and to run forward. If you have animations for moving sideways or moving backwards, you can get the input and apply it to our movement vector, but we are going to only apply transform forward to move forward. So let's call movement vector equals transform dot forward times movement speed. Okay, but what happens if we are pressing the arrow to the right or to the left? Well, then we want to set our movement vector to be vector 3 to be equal to vector 3.0. Okay, because we want to stop our character from moving if it is moving. Otherwise, it will be constantly moving forward or in the direction that we are pointing. Let's implement our update, because the update will take care of moving our character controller. So here we want to apply our gravity. To do that, we are going to call movement vector dot y minus equals gravity. Okay, and what else? We need to apply to our controller this vector of movement. So let's call controller dot move, and we are going to say movement vector times time dot delta time. So this will make our character move in the forward direction and apply gravity to it, so we detect that if we are grounded or not. So let's save it. And before we go testing it, let's implement simple handle direction, because now we will need to assign those to our input callbacks as our input callbacks. So let's create public void handle movement direction, and let's take vector 3 direction. Okay, and for now let's leave it empty. So now we can go to our agent controller script. Okay, and beside our I input we are going to search for agent movement. Let's call it movement. Okay, and now instead of printing our debug statements, we are going to call here our movement dot handle movement direction. I think we have this, yes. And in the on movement input, we are going to assign movement dot handle movement. Okay, but before that we need to call movement equals get component of type agent movement. Okay, everything should be working now. Now, one good practice is to always unassign our listeners from our delegates. So let's create on disable. So if we disable our player, let's copy those two statements and instead unassign those handlers. So we are sure that those delegates will not call something that doesn't exist. And now we should consider that if we disable our player and re-enable it, the input will not work, so we should probably change it from start to on enable. Okay, now we have everything, so let's go to Unity. Okay, let's open our player, and we can drag here our agent movement. And for it to work, let's set the movement speed to 7 and rotation speed to 8. Okay, let's save it. Now let's clear our console, let's press play. And now we should be able to press forward, and we can see that our player is indeed moving. He is not rotating and he is not playing an animation. So let's go back to our agent movement script. So let's start from the issue of facing the correct direction when we are moving. So we will need to input some code here in the handle movement direction method. I am going to use Ctrl+RR to rename it. Okay. And now what we will need to do here is to calculate the angle between the forward direction and the direction we want to face to know where should we rotate. So let's call desired angle, the float value that we have implemented previously, equals vector3.angle. This method will calculate our angle from 2. So from our vector is our transform dot forward, which is the direction we want to rotate from, and we want to rotate towards the direction vector. Okay. Now there is one little issue. The angle is always positive. So to deal with it, we need to consider calculating the cross product of those two vectors to find if we want to rotate to the right or to the left. So let's call var cross product equals vector3 that cross, and we need to call transform dot forward and our direction, and what we need to get is y value. Because we are moving in the xz plane, the cross product will have 0 as x, 0 as z, and its y value will be either positive if we are rotating to the right or negative if we are rotating to the left on our y-axis. So if we want to rotate to the left, we need to set our angle to be minus. Let's see in Unity. Okay, let's choose our player. If we add rotation on minus, we are rotating to the left. If we are adding rotation on the plus to the y-axis, we are rotating to the right. And that's what we need to figure out, what is the sign of our angle. So let's go back to our code. Okay, so to figure it out, all we need to calculate is the cross product and know its y-axis, and this is just because we are moving on the xz plane. So if our cross product is less than 0, we need to set our desired angle rotation times equal -1. Okay, and we have our desired rotation angle. So now what? We need to create a separate method. Let's call it private void rotate agent. Okay, and here inside this method we are going to check if our desired rotation angle is greater than 10 or our desired angle rotation angle is less than -10. So this is the threshold. If this is the case, we are going to call transform.rotate, and we are going to rotate around vector3.up, which is y-axis time desired rotation angle time rotation speed and times time.delta time to make it smooth. Okay, and now we need to call this method somewhere. So let's slide down to the update, and we want to rotate only if we are moving. So if our player is standing still, we want to be able to rotate the camera and look around without the player moving around. Of course, if you want to rotate the player around with the camera constantly, you don't need to apply this if statement. So if our controller is grounded, so this prevents rotating during the jumping state. If our movement vector dot magnitude is greater than 0, so this makes only rotation only possible when we are moving, we're going to call rotate our agent. Okay, great. So let's go to Unity and test it. Let's press play. And we can still rotate the camera, and we can see that our player is moving in the direction that our camera is pointing towards. Okay, let's stop the game. Let's go back to our code and let's quickly add the animation. So we need to get the reference to our animator. Let's call it animator. Okay, in the start, we need to get animator dot equals get component animator. Great. Now in the handle movement, as I said before, we will call animator set float, and this is the float that we have preset in our blend tree. It was called move, and we want to set it to 0, so we do not want to play any animation, so basically the animation idle, when we are standing still, which is nothing strange. So what next? How can we play the correct animation depending on what we are doing? Well, let's create a new method just above the update. Let's call it set correct animation. So private float set correct animation. Okay, and what we will need to consider here is that when we are rotating, because we are standing possibly 180 degrees to the direction that the camera is facing, we shouldn't instantly start running. We should slowly turn around and only then start running. So to implement it, we are going to return here the float value, and this float will be float current animation speed. And we are going to assign it to animator get float, and this will be our move value. Now if we have this, we can do the same check as for rotation. So desired rotation angle is greater than 10 or desired rotation angle is less than 10, which indicates that we want to rotate. If we do, we need to check if current animation speed, and if this is less than 0.2, which was our threshold that we have set for our animation, we want to add to it current animation speed plus equals time dot delta time times 2. Okay, and we need to consider what happens if the current animation speed is set now to be greater than 0.2 value, because then our agent will start running. So we need to call current animation speed equals math.f.clamp, and we want to call current animation speed and clamp it before 0 and 0.2f. So this will ensure that when we are rotating, we are only playing the walk animation. Okay, so let's call else when we are checking for the desired angle, and before that we need to set our animator set float, our move, and let's set it to our current animation speed. Okay, so if the desired angle is less than those thresholds, we are going to check if our current animation speed is less than 1. We are going to set it the same, basically what we have above, which is plus equals time the delta time times 2. Else, if this is greater than 1, we are going to set current speed equals 1. Okay, and at the end, let's copy the same animator set float from above. Let's paste it, and we want to return our value of the speed, so current animation speed. Okay, and I see a mistake here. We are checking if it is greater than 10, but we need to check if it is less than minus 10. Okay, and we need to call this method somewhere. So let's slide down to the update function, and here inside our if statement, above our rotate agent, we are going to call var animation speed multiplier equals set correct animation. And what is left is to multiply our movement vector times equals our animation speed multiplier. So if we are only walking to rotate, we don't want to move too fast, so we are going to multiply the movement vector by our animation speed multiplier to decrease the movement speed. And if we are completely rotated, animation speed multiplier is 1, so we are moving just as we are supposed to move. And that's it. So let's go back to Unity. Okay, so let's test our game now. And we can see that our player is currently rotating and start running when we are running towards the camera direction. Now if we rotate it around, it slowly rotates around, well, not so much slowly, but it rotates and only walks. Only then it starts running. So we have our character controller for our player implemented. In the next video, we will take care of implementing an AI agent controller. So let's see you in the next video.